Alright, section 1.3, we're finishing this up hopefully today. Let's do an example of division. So here we go. I've got negative 8 r cubed s minus 12 r squared s squared plus 20 rs cubed. Now we're dividing. Now in algebra a lot of times, remember back in the day when you were a kid you did division like this. Do you remember this? You divided. Okay, you did that division. Well, we're not going to see that all that often in algebra. Usually when they show division, they show it kind of as a fraction, right? Big old fraction bar right here. That means to divide. And this time we're dividing by 4rs. Alright, now when you're dividing, remember you can always cancel stuff out. Like if I had this, if I had x cubed y divided by x squared y to the third. Okay, what could we do when we divide this stuff out? Look, this is how I do it. You could subtract the exponents. Remember we learned that rule? Subtracting the exponents. But watch, this is the way I like to think of it. I like to think of it as this. This x cubed means there's 3 x's up here, doesn't it? X times x times x. This x squared means there's 2 x's down the bottom. So I'm canceling stuff out, right? So I'm taking 2 of the x's on the bottom, canceling with 2 of the x's on top. How many are going to be left over? Just 1, right? So 2 of those, just 1 left over. Do you see that? Instead of thinking subtract, I like to think of it like that. So this thing completely canceled out. What about this? This is y to the first. I got 1 y on the top and 3 on the bottom. So one of these y's cancels with what? One of these. How many do I have left? I have 2 of them. So what is this? It's going to be x over what? Y squared. Does that make sense to you? Okay. We're going to kind of do the same thing here, but I've got 3 different terms up here that are dividing by the same thing. This is what you have to remember. A lot of people forget this. A lot of people say, oh, that and that cancel out. The r right here cancels out with one of these r's. This s cancels out with one of these s's. And boom, that's gone. Is it gone? No, you're not just dividing by this. You're dividing by all 3 of these terms. You're dividing by this term. You're dividing by this middle one. And you're also dividing by this third one. Does that make sense? Okay, so what I like to do, just to make it a little easier for you, I like to split it up and to show that this is being divided, the second one's being divided, and the third one's being divided by 4rs. So I'm going to write it as 3 separate problems, if you want to think of it that way. So I'm going to write it negative 8r cubed s over 4rs minus 12r squared, r squared s squared over 4rs, and then plus 20 rs cubed over 4rs. Same thing, isn't it? Because look, if I started off with this, I just have a common denominator, right? So I can write all my stuff over that one common denominator. Would you agree? I could go from here to here, and that's what I would get. So all I'm doing is going the other way. I'm just taking it, I'm saying, oh, everything's being divided by 4rs, so I write it like this. I think this is a little easier. So let's see what happens. 4 goes into 8 how many times? Twice. All right, so what do I have? I got a negative 2. What about this? One of these goes with one of these, so I have a r squared. And the s cancels out. They both cancel each other out. So that's what my first term is. Okay, no denominator, right? Because all the denominator canceled out. Let's put a minus. Let's see what happens here. 4 goes into 12, doesn't it? 3 times. Look at this. This 1r goes into one of these 1 times. Okay? And then watch. One of these s's go into one of these 1 time. So what do I have? I got a minus 3. What else do I have? Just an r and just an s. Good so far? It's pretty easy, isn't it? Just basic canceling stuff out. Division is what it is. Look, 4 goes into 20 5 times. R divides into R. They go even, right? They cancel each other out. And this s, one of these s's cancels with one of these. How many do we have left over? 2. So this is just what? 5 s squared. That's it. You can't add those up, can you? All right, because they're not like terms. That's got an r squared, this has an rs, this has an s squared. None of them are like terms. even though they do have a little bit of similarities, but they're not exactly the same. So you can't add them up. You keep it like that, you circle it, and you're done. We good with that? Yep, I think it's pretty easy. That's definitely the easiest division problem that you're going to do. All right, we're going to get a little bit tougher than that. Now, I don't even have one of those on the worksheet that I'm giving you. I probably should have put one on there, but I didn't. So, but that could be on a quiz or a test, though. All right, so just because it's not on this worksheet doesn't mean you might not see it again. So it's in your notes. Make sure you know how to do this. Again, if you want to go to the book, you can find a few more problems like this on page 35. All right, if you want to look there. All right. There's not a whole lot of those. There's just a couple of them. But you can at least get a couple more of those. Okay? All right, let's go to the division that we really want to work on today. What we're going to do is we're going to do division again, but we're going to do a long division. And I'll show you. Let's go back in time for a little bit. What if I had this? What if I had 7 divided by 8? And I wanted you to write that as a decimal, or do that division. 7 divided by 8. Well, you write it as a long division. We're not putting it into a calculator. We're going to do a long division problem. Remember doing this? Okay. I remember when I was in 7th grade, Mrs. Borgness was her name. Okay? Still remember her name. And Borgness, B-O-R-G-N-I-S. Borgness, yes. 7th grade math. And she was an older lady. She was pretty interesting. I remember she used to show us slides. She used to travel to Europe a lot. She would show us slides in class, and I always enjoyed that. And I've done that before. I actually you don't even know what slides are? Okay, they're like little, and they're little, yeah, and you stick them in the carousel and click, click, click. Yeah. You ever watch any of those? I have tons and tons of slides because my dad always took slides all the time. Well, anyway, that's Mrs. Borgness. She taught me this, and for some reason, I remember that she taught me this. And whenever, I mean, right now, I always remember which one goes in there. But when I was a kid, I could never remember which one of these goes in the box. She would call this the box. I know there's more mathy kind of names for this, but she called this the box. So she said, well, the top goes in the box. Box top. If you can remember box top, then the top one goes in the box. For some reason, I was just hard-headed, and for some reason I could never remember which one went in here. I always got confused. So when she told me box top, it just clicked. And I was like, oh, I can remember that. So the top one goes in the box. You with me on that? All right. Maybe that's never been a problem for you. It was for me when I was a kid, so now that helps me out. So box top. Of course, the bottom one would go outside like this. Now, if we're going to do a long division, let's put a decimal. And what do we usually fill in with? A few zeros, right? All right. Put a couple zeros there. We'll see how far we have to go. All right, maybe put one more. What do we do with that decimal? Stick it right up here. Now watch, I'm doing this for a reason. Okay, I want us to follow these steps because we're going to do polynomials with exponents and variables the same kind of way, the same basic format that we're going to do here. So what's the first thing we do? We take this thing on the outside. We say how many times does 8 divide evenly, or not? Yeah, how many times does 8 divide evenly into 70? Well, it may not go even, but how many times does 8 go into 70? How many times? Come on. How many times does 8 go into 70? Well, it can't go 9, because 9 times 8 is 72. So it goes what? 8 times. Okay, you got to learn your multiplication tables, and I have a feeling that you're not up on those. And why aren't you up on those? Come on, you know why. Tell me. Talk to me. Come on. Because you use a calculator all the time. Exactly right. Okay? So anyway, so 8 times 8. So what is that? That's 64. So what do we do with that 64? We subtract. You remember that step? All right. So we say how many times is 8? Divide evenly into 70. Well, 8 times. Now, it doesn't go even into 70, but how many times does 8 go into 70? 8 times with a little bit left over, right? So what's the little bit left over? You subtract, and it's 6. Follow me? Now, what do we do next? Drop down to 0. All right. So we drop down to 0 and put it right here. Now, if these were other numbers, right, you've done long division where these have been a whole bunch of other different numbers, right? If they're different numbers, you take whatever that number is and you drop it straight down. We good? All right. Go through the same routine again, right? How many times does 8 divide into what this time? Not 70 again, but what? Into 60. How many times does 8 go into 60? Think about it. 7 times. 7 times. Right. Because 8 times 7 is 56. What do we do with that 56? We subtract it. Now, when you're a kid, you had a tendency to leave out that subtraction right there just because you went a little quick. I did anyway. I don't know if you did, but I always did. But it's important. It's very important what we're going to do next that you keep that subtraction there. Is that okay? All right, we're almost done. Subtract, what do you get? A 4. Bring this down, and then that's a, what? 5. Oh, you said 5. I wrote down a 5. I know what you mean. Right, I know exactly what you meant. All right, so you bring that down, that's a 0. So how many times does 8 divide into 40? 5 times. And then 8 times 5 is 40. We subtract a 40, and you get what? 0. So your remainder is 0. Now sometimes when you did these long division problems, you actually got a number here for a remainder, didn't you? Now, we didn't on this problem. Let's just pretend, I don't know, we got a 3. We're just pretending, okay? I know this isn't for this problem, but what if we had a 3? When you're a little kid, what'd you do? You put R3, didn't you? But then you grew up a little bit, you learned a little bit more math, then what'd you do with that remainder? You wrote it as a what? You wrote it as a, well, you wrote it as a fraction. Now, you probably would not combine, this is kind of off a little bit, but you wouldn't combine a decimal and a fraction. But let's say you had a regular long division, no decimals, okay? Right? We're thinking outside the box here. Let's say, what would you do with that remainder? You would put it over what you're dividing by. Do you remember doing that? Writing your remainder? You never did that? Are you serious? Well, anyway, that's how you would do it. You would write it 3, whatever your remainder is, and you put it over 8. When you're a little kid, you do that R thing. But then, you know, you learned a little bit more, and then you went 3 over whatever your divider was. Now, of course, this doesn't all work because that's not a 3 to begin with and all that kind of stuff. So let's I'll tell you what, let's just get rid of some of this. Get rid of all that remainder. There we go. All right. So, I'll just kind of scooch this. Oops. Let's try it again. If I can grab it. There we go. I'm just going to scooch this right here. Equals, alright, and then I'm gonna take that thing, I'm gonna shrink it down a little bit just to give myself some more room. I want to keep this though over off to the side just so I can remember what I was gonna do. Now what we're gonna do is we're gonna do a long division problem. Let me go to the next video because I don't have enough time here to squeeze that in. Alright.